All right, it's great to be here. Thanks for having me. I will talk about the cell phone networks, plural, that we've been running here at the conference. So, brief introduction. I'll talk about the process of setting up this test network, so the steps that are needed in order to make this happen. I will talk about some technical stuff, what we actually have been running here. I will compare this with some of the previous installations that we've done at CCC events over the last few years. I'll talk a little bit about the challenges that we've faced. Actually, even though we've moved to a new location, this turned out to be very manageable to set up. I promise to show some statistics, and I'll try to make some concluding remarks. My name is Peter. I moved from Sweden to Berlin a couple of years ago. I like to do software, hardware, security things, electronics, open source. You may know me from presenting various other projects here or elsewhere. I've been involved in running the GSM networks at the CCC camp last year, C3 last year. I went to Burning Man and helped run the GSM network there this year, and finally here in Hamburg. So the process for setting up this test network, we need to take a look at the area that we want to provide coverage to see, well, how many base stations do we need? Where can we put them? Where is there good connectivity? Where is there power that we need to run them? We need to consider what kind of signal propagation there is. So if it's inside a building, if it's outdoors, are there trees in the way? Are there large buildings in the way? Or indoors, are there walls in the way? Any kind of metal surface is really good at causing problems for any radio communication. So we need to keep that in mind. If we have a metal box or a room with metal walls or reinforced concrete, then that is going to shield very effectively any radio signal that we have outside or inside. So yes, keeping that in mind is important. We make a plan for cell site deployment, so sort of a rough idea of what we want to put where in order to make this work. And it's a good idea to make a backup plan also, because even though if we go to the area, even if we have the ability to go to the area, we might not be able to make all tests right up front, and we may discover that actually the things we planned to do that didn't really work out. We are operating in Germany, so we also need to send a request for a test license to the Bundesnetzagentur in order to be allowed to actually run this network, because we're transmitting radio signals. So this is important, and we sent that in, I think in September, maybe possibly October, and yeah, then we wait. And we wait some more, and then when it starts getting mid-December, we get a bit nervous because we haven't heard anything back. But yeah, the license arrived just in time, and everyone is really happy. So meanwhile, we can of course continue and configure the stuff that we're going to run here. We configure the hardware, and we think about things like where do we mount the equipment that we want to deploy, how do we mount it securely so that it doesn't fall down and hurt anyone, so that it doesn't disappear. We configure software. Now, since we've been doing this for a few different events already, we have a setup that we carry with us, and as some of you may know, if you have a SIM card from any of the previous events, they continue to work because we carry the database along with us with all the subscriber information, or well, all the SIM card information. Even so, we have to program new SIM cards as well, because not everyone has a SIM card, or I talked to several people who did get SIM cards at a previous event, but they forgot them at home, or they didn't know that they would work again. And of course, there are new visitors who also want to use the network and help test things out. So when we arrive on location, the next step is to to start doing some testing, rig some kind of temporary base station in some of the locations that we have in mind, and see how it works. So there are some models mathematical models for calculating radio signal propagations, but there's really nothing that beats empirical testing. So just setting something up very quickly and walking around with a cell phone and maybe the Osmocom BB phones that have a special monitoring mode or a monitoring software that was developed by the community and which is also open source. You've heard about that previously. Using that as a measurement tool is very valuable, or there are a couple of other popular phones, the Nokia 3310, for example, that are also very useful for monitoring networks. And yeah, once we've sort of, I guess, iterated over our deployment plan, we simply deploy. We put out all the base stations and hook them up to power and backhaul. So I mentioned networks, and there are two logos here. We have actually been running both OpenBSC and OpenBTS, not at the same time, well, for a brief period at the same time, but mostly separately with a strong emphasis on OpenBSC. We didn't run OpenBTS for very long periods of time. We'll see that a bit later. It's shown in the graphs. Some background on these projects in case you don't already know of them. BSC stands for Base Station Controller. That's a standardized part of a traditional GSM network, all documented in the thousands of pages of specification. It's a part of the Osmocom open source mobile communications family of projects. It is a project that was started by Harald Welte in 2008, a couple of years ago. And what it does is we use standard BTS hardware, which is also used by commercial networks and have been around for a very long time. The actual radio hardware is a product that can be bought from the suppliers or from the manufacturers. But we replace the control software that is running normally on a separate or always on a separate piece of hardware and controls these radio units. The radio units are BTS, are called BTS, and the BSC is, well, the base station controller. So it controls one or more of these units, and this control is replaced by, or is performed by OpenBSC, the open source software. OpenBSC follows a model of the traditional GSM networks. It likes to use many of the standard protocols that have been defined in the traditional GSM specifications, and it's structured and implements much of how traditional GSM networks work. OpenBTS I also mentioned. So BTS is short for Base Transceiver Station, but yeah, and OpenBTS open source project also started by David Burgess and Harman Samra also in 2008. It takes a different approach. It implements a GSM. It implements the GSM radio communication using software-defined radio. So instead of using a factory or a product that was bought from someone, it's a software-defined radio with which implements exactly the GSM radio communication. And what it does, the big difference, so the communication over radio is identical between whatever way you do, otherwise it won't work at all with mobile phones. It has to follow the standard. So both of these products, or both of these software projects, they implement the correct GSM signaling. And the big difference is really in the back-end side, where OpenBSC, again, it follows the more traditional GSM network implementation or GSM network model, whereas OpenBTS has a ZIP backend directly. So someone has said that OpenBTS is sort of the internet reaching out to mobile phones, whereas OpenBSC is more of an internet engineer sort of perspective on how GSM networks traditionally work. So two different projects. They've been around for about as long. I've always thought that it would be really nice to somehow combine them, and I'm happy that we've had the opportunity to work together here this year. So the OpenBSC installation is what I'll go into detail about, because I helped set that up. I didn't work with the other part. We had 5 BTSs set up in the CCH, about 1 per floor, roughly. There's 1 on the ground floor hanging from the ceiling next to the elevators. There is with an omnidirectional antenna, so it has a covers the most of the ground floor, if not all of the ground floor. There's 1 on the first floor in our room. There's 1 on the second floor, next to the elevators on the other side in the foyer number 2. On the 3rd or 4th floor, there's 1 here up on the balcony. And on the 4th floor in the far end of the building, there is 1 installation on top of a fridge in the bar. And this setup, it brings us, with the nano-BTS units, it brings us moderate to really good coverage throughout all of this building. And actually, we were able to have some communication even by the Dammtor train station. So comparing this with previous events, at the CCC camp, we were also using OpenBSC. We had, however, completely different hardware. We were using the Nokia Metro site BTS hardware, which has an ISDN backhaul. So we needed to use an ISDN card in our server machine. And we had 2 sites at the camp. They were pretty far away. We had antenna towers mounted on 2 bunkers. Well, 1 antenna tower and 1 antenna mounted on top of the bunker. They were far away, and we had to run an ISDN E1 cable between these 2 sites. So that turned out to be over 180 meters of Cat5 cable, which exceeds actually the maximum length of ISDN cabling. But it worked reliably anyway, fortunately. 28C3, we again using OpenBSC. That's what we've been using the most here. Also, many of the local people are actively working on these projects. So on the OpenBSC project, so that tends to be what we know the best and what we work with. We had at 28C3 in the BCC 3 sites, again 1 per floor. We were using the same kind of BTS hardware, but we had configured them to work together. So they were deployed in pairs. On each floor there were 2 BTSs. TRX stands for transceiver. So in total 6 BTSs, actually more BTSs, but because they were deployed, connected together in the same spot, while they allowed more channels, more calls being active, they did not cover as large an area as we have been able to do here in the CCH. And yes, of course, that was using also a local area network backhaul, which is so incredibly convenient compared to the ISDN stuff. Especially with technology like VLANs, you can talk to the network guys and say, well, we would like to deploy our BTSs there and there and there, and magically you have a completely separated network on just a couple of different random ports throughout the building. So some challenges. As I mentioned in the start, surprisingly few challenges. We have found that it's pretty easy even for private individuals to request and to be assigned a test license. There's an administrative cost associated with this. You have to pay, I think, on the order of 200 euros. You can apply for a license that runs for 1 year. Then you have to pay a much smaller fee to renew this license. That's how we found that it works. And as far as I know, none of the requests that have been made for for test licenses have actually been declined. So it seems that this is really something that is easy to test out, and we learned that it's really helpful for the Bundesnetzagentur to specify very clearly what it is we want to actually test with this test license. So be specific if you want to make an application. Be specific about the hardware that you want to use, about the software that you want to use, and yes, because that of course helps them know what is going on, and perhaps it also helps them make a quicker decision. So if you have a deadline, or if you're doing this for an event where you need to, where you have access to users so that you can test your software, or, well, our software maybe, the Osmocom software, then keep in mind to request this test license in some good time, because it's no fun to not be able to run the network just because you haven't gotten a response yet. When we first visited the CCH here, we were somewhat worried about the walls of the building. For instance, this is a really big room, and so the walls have to be strong. We were thinking that might be a problem if they were reinforced metal, had metal inside of them, that it would somehow limit, or that it would limit the signal significantly. But actually this turned out to be not such a big problem. It works. It works very good, the propagation here. We arrived early, and we did a bunch of testing while we were waiting for the network operations center to get the network up and running. I don't know if you know already, but actually the NOC has replaced pretty much all the network infrastructure in the building for the Congress network to make it powerful enough and good enough for what we need to do. And this of course takes some time. It's a big building, so yeah, we were a bit blocked by that, but in the end it worked out well. I tried to take some photos while we were doing this that I'd like to show. Here's a stack of SIM cards. As I mentioned, programming SIM cards is part of the fun. It's a bit repetitive, but it's pretty quick, so it's not so bad. We've automated and written some scripts there, available in the PySim repository if you want to have a look. I don't know if you can see this. This is one table of gear in our room. Here's the BTS on the ground floor. Maybe you've seen it. How many have seen it already? No, all right, about 30%. Very good. Here's some testing we were doing inside the room. We needed to mount antennas, of course, and we mounted antennas in a few really good places, really good locations. We were able to find some good locations, but we didn't bring maybe all the mounting hardware that we actually needed. So then we had to improvise a bit. We had some SIM cards left over, well, the plastic around the actual mini SIM left over. So we made some washers with that, and sometimes you need to transport a ladder and it doesn't fit in the elevator, so try the next elevator, and because it's a big ladder, that's how it goes. Finally, we were able to use the SIM card plastic pieces here to fit the antenna into this rail in the ceiling. That worked out well. Here's the antenna on the fridge over at the bar. Yeah, more SIM cards. Can you read this, actually? Okay, no, maybe not. This is the test license, anyway, that we have. It says 1780 to 1784 and 0.4 and 1875.8 to 1879.4 megahertz, which we are allowed to use. Issued on the 10th of December. More workspace. This is, it's gotten even more crowded, and well, crowded. More crowded than this is pretty easy actually, because there are no people there. But it's gotten more full, and we have more, even more papers on the walls and so on to keep track on of what exactly is going on. I'd like to talk a bit about fun use cases. So we had some remarkable use cases that I really liked. This is a laptop. I don't know if you can see what it says on the screen. It says root at Effica MX and Python sms.py. 9899 at some timestamp was sending an SMS with the contents !curl. So 9899, that's my extension. We found this machine running on the network and receiving SMSs with interesting contents, and sending back SMSs also with interesting contents. It turned out that someone had set up a root shell via SMS service on this laptop. So I sent it my public SSH key. And yeah, actually that worked out, so I was able to log into the laptop afterwards. We had some testing equipment in the room. We made some load tests. This is a box with 16 GSM modems. We used it to, yes, as I said, load test the network, and we were able to find at least one bug that got fixed. So that's good. I promised some statistics as well. Numbers on the left, let's see. So the timeline is clock, Central European time, local time. The big spike there, just before, so here in the evening of the 27th of day one, is a bug in the statistics script. So that's an anomaly. We didn't clear it out. We could have, but I thought it was nicer to leave it in to sort of really show that we also had some bit of chaos, even though things worked pretty well. There are some sections of flat. Just flat here, no change in the numbers, no activity at all. Those are the two periods where we also tested OpenBTS. And one thing that is particularly fantastic about this network, or these networks, is that for a very brief time, we were able to run both networks at the same time. That hasn't been done before. In the middle between them, we're using the software LCR, Linux Call Router, which by now knows how to speak natively with OpenBSC, and it also knows how to speak SIP. So one of the common use cases, and something that I've used it for before, or yes, one time, is to have OpenBSC with a SIP connect to a SIP network. So somehow similar to how OpenBTS works, but using OpenBSC instead, and that worked. Here we were able to make it also talk to OpenBTS at the same time. So if you would call a GSM number, it would try to ring in both networks. And of course, a given phone was only ever in one network. So then it would ring, of course, because it was being called in both networks, but the other network would just know that the subscriber is not available, and cancel the ringing. But thanks to LCR, this works. I think that's I'm really happy about that. So I wanted to mention it. I think it's a pretty cool combination of the two projects. So I want to say some personal thanks as well to Harald Welte and Holger Freite at Sysmocom. Harald unfortunately didn't make it, isn't here for 29C3. He's still in Berlin. Holger is here and has been helping out really great, and all their preparation in advance is really what has allowed us to set up this network at all. I also want to say a very, very special thanks to the heroes and the heroines of the NOC. They were working really, really hard to set everything up, and I was kind of a pain running over there and asking for extra changes. I did some requests in advance, but everything changed once we got on site. Of course, the OpenBSC community, as always, and the OpenBTS community for working on these softwares. It's fantastic what we're able to do with them. I want to say a special thanks to Nico and Kevin, who made the lovely graphics. And also thanks to EventPhone and the POC for helping us connect to the DEC network, because as you might have noticed, I don't know if Peter asked about it, it's possible to also call between the DEC and the GSM network in both directions, and that reminds me of another really nice use case. We, at some point, I think day 1 or possibly day 2, we had made some modification to the code, and we wanted to restart OpenBSC. But so when we do that, we will also, of course, close all active calls. And we saw that there was one really long-running phone call. We didn't really want to just abort this, stop this call. So we started looking at where, first of all, where the person was, what BTS it was connected to, the phone, and the number that it was calling. And it turned out that it was someone sitting here in Saal 1 and who was making a very long phone call to the translation service over GSM. So we of course waited until the presentation was over, and then we restarted. So in conclusion, running a GSM network can be pretty easy, even if you're at home. The BTS hardware that we've been using here is a bit expensive for hobbyist use, but I've talked to several people at, for example, a hackerspace who are interested in pooling some money and buying one of these base stations in order to set up a test network at their hackerspace. I think that's a fantastic idea to try this out. Make sure to get the license, so check what the rules are in your country. In Germany, it's pretty easy. I saw that in Sweden, it seems also pretty easy. The PTS, the government authority in Sweden responsible for radio spectrum, they have a good procedure and a really good documentation for how to apply for these test licenses, and it doesn't seem like a big deal at all. It's worth mentioning also that the GSM 1800 megahertz band, so watch out with that. If you want to get started with this and you want to you're in the market for some kind of equipment, check that especially if you're buying used equipment, check that it actually fits the area where you are, the geographical area, because throughout the world GSM uses a bit different frequencies. And in Germany, for example, we have 900 and 1800 megahertz, where the 900 megahertz band is completely full. There are no available frequencies anymore. It's all used by commercial operators. So the only part of the frequency spectrum that is available for test licenses is the 1800 megahertz band. And Sometimes it's possible to find BTS units that have been used or being sold used that come from the US, and maybe they come at a good price, but pay attention because in the US they use a 1900 megahertz frequency band instead, and that unit won't really work in the 18 megahertz band. So make sure to get the right hardware and make sure to get a license. The configuration files are incredibly actually simple. There is a nano-BTS example in the OpenBSC source. The LCR configuration files are short and sweet. I will make sure to upload those or give them to anyone who's interested. Come talk to us. Yes, that's what I have. In closing, here's a tag cloud. Oh, well, sort of centered. A tag cloud from the SMS messages that you've been sending. Happy hacking.
Thank you, Peter. We will take any questions at microphones 1, 2, 3, and 4, so please line up there. And we have a bunch of questions from IRC, I see. We have 2. So let's start with IRC. Do you have a microphone?
Okay, so first question is, how much does a license cost in Germany, and what happens if you don't get one?
So I mentioned the costs that I've seen is about 200, on the order of 200 euros for the first year. And if you want to renew the license in Germany, you pay a much smaller fee. So I haven't seen the invoice myself, but I've been told that it's about 35 euros per year for renewing a license that you already have. So it's affordable. What happens if you don't have a license? Well, you can't run the network. It's that simple.
But will they notice? Is the question, do they come here with vans and with an antenna on top? And
I've heard about accidents happening where, honest accidents, where someone had automated a BTS running at their home. And after, so they had tested it. They were working with this at the university. They had replicated a setup at home, or they had brought the setup home to work on it there. It was configured to boot up automatically after, boot up automatically. And after a power outage, the system started on its own when this person wasn't at home. And as the person arrived at home, they were greeted by the Bundesnetzagentur, who were standing in front of the door, and with a measurement device and saying, "Here, there's a thing here. What is this?" So it's very, very simple.
okay, thanks.
If you don't have the license, you can't run the network.
And also very expensive. The cost for those people who then come by and analyze, it can be easily several thousand euros.
I'm sure it can be way more also, yes.
Okay, next question from microphone number 1.
What's about DTMF? On Friday, I was able to deliver some DTMF tones to my cold party, and it works quite fine. And on Saturday, I mean yesterday, I wasn't absolutely unable, and I observed that some of my tones were doubled. So what is the state?
As I mentioned, there were 2 different networks running at different times, so probably the DTMF worked in one of the networks and the other, and not in the other. And depending on exactly what time you made the tests, we would have to check in the log files, maybe. Stop by the room and let's find out exactly.
But just for education, when it doesn't work, what is the problem?
Well, quite likely there's a codec problem. So somewhere along the line of the audio that is being transmitted, there is a codec, a software that is changing the way the audio is digitized into a different format, and DTMF is some kind of signaling. It's a very simple signaling on top of an audio stream. If the codec is aggressive or is compressing hard enough, then it might actually destroy the DTMF signaling. So I think it's likely a codec issue.
Thank you. Number 2.
Could we have another look at the graphics, the representation of the usage of the network? Because if I'm not mistaken, in the beginning there are for several hours no active users at all, while all the SMSs and the light blue line between 0 and 12, there seem to be no active subscribers, while there are happily all sorts of calls and SMSs.
Well, a small number of subscribers can make many calls and send many SMSs.
I even would have attributed that to another glitch in the charting software. But I noticed at some point in time that when I tried to activate my mobile, that it didn't work over several hours. So I think there might be something to it in this case.
Yes, it's possible, especially so on day 1, the first 24 hours, we were still doing setup around the building, so it's absolutely possible that there was very little activity. And up until this glitch here, the statistics may not be 100% reliable. I think they are good, but it's possible that there were bugs there that weren't fixed until after this big glitch.
Microphone number 3.
I'd like to thank you first for setting up and running this awesome network and for producing this great software.
Yes, thank you.
Well, don't. It's not me. I helped set it up.
Anyways,
but the communities of these projects are are quite amazing.
I was wondering if you're planning to build 3G or 4G software in the future, and if yes, how can I contribute?
I know that there has been some work on 3G. I know that it's significantly harder than the 2G, the legacy GSM. I guess it's a matter of time, how much time people can spend on working on this, and if there's and motivation, of course. So how can you contribute? I suggest to join the mailing lists and come talk to us in the room, of course, also. We're still here for all of today, and maybe someone will even be here tomorrow, and see what you can do. LTE. So personally, this is just speculation, but personally, I think that maybe UMTS will not get so much attention, and that focus will instead be on LTE to sort of make a leap instead of going over UMTS, because there's so much effort involved that in doing both of those or doing either of those, that since there is a new standard, maybe it makes more sense to go straight for the LTE. But let's see what happens. In the end, it comes down to who contributes and who has an interest in doing either of these.
Okay, thank you.
Next question from the internet. Can we get the microphone up to the signaling?
Question was if handover works between the OpenBSC and OpenBTS networks.
Oh, so yes, interesting question. Good question. Handover has been tested in the two networks separately, but there is no handover between the two networks. So we were just barely able to make a call between the two. We don't have a bridge for SIP, for SMS. So yeah, no handover at this time. I think that would be fantastic, of course, but no, there was some handover testing done in the two networks separately, but not between the networks.
Microphone number 4.
Yeah, hi, Peter. I'd like to know, if possible, a few things. One, I'd like to know what hardware is installed in the different 5 floors where you mentioned the different things specifically, and what kind of power output is going on there. I'd also like to know if there's some statistics. The statistics are very positive, and that's great and all. Personally, I didn't use the phone as much as I thought I might, but the 2 times I did actually try to use the phone, it didn't work. Which was kind of unfortunate, but I've had lots of experience with this. I know what's going on, but I wondered, are there any statistics that are more kind of negative? You know, how many calls were dropped? How many SMSs failed? Do you have anything on when handover worked, or I don't really sure if handover is an issue in OpenBSC with the hardware that you're using, if it just works or if it works sometimes and sometimes not, because it's quite experimental in OpenBTS, I know. So I'd like to know also some of the results from the load testing tests. These may be things that I can meet with the GSM people later and get these specific information. It's quite a lot to ask for in this session. But there's those things, and also just another comment. I found one fixed phone down by the door, and I thought that I didn't see them around, or I didn't really find much information very easily on where people could access fixed phones in order to be able to call GSM phones, because I did also mention to a couple of people, oh, you can call me on my GSM, and they said, I don't have a phone. So, you know, I think that would be something that would be really good at these events if there were a lot of fixed phones around, you know. It's a pretty easy thing to do, I think. Thank you.
Thank you. So I will try to answer as best as I can. We have NanoBTS hardware running IP access on the floors, and so we have 3 watts of output power in the. We're allowed to use 3 watts of output power in the license. We're not using that, all of that. The other question was negative results. We have plenty of log files, but we didn't look for negative results yet. It's a good idea. I think we should. As for dropped SMSs, me and another guy in Berlin, Tobias, we want to work on an SMSC that can be shared. We are working on an SMSC that can be shared also in both OpenBTS and OpenBSC. It's not finished to a point where we could actually use it this time here. We would have liked to, but still work to do. Once we have that working, I think so here's the thing, SMS is a little bit shaky in both OpenBSC and OpenBTS in my experience. It does work. It's not that things get randomly dropped, but so it could be better, and we hope that we can make a leap in performance with the SMSC software. So there wasn't much focus on, because the development effort for this SMSC is ongoing, there wasn't much focus on quality of service for SMS. I mean, we saw things like the root shell working, and the tag cloud, and we have what here submitted SMS 6000 something. So it's not that it doesn't work. It works really. It really works, but we hope to get even more performance, a big leap in performance with the new SMSC software. So yeah, no, not much focus on that. Third question.
I asked about load testing.
Load testing, exactly.
Results.
Yes. Please come over to the room and talk to the respective people who did the actual testing. They will be able to get you the exact results.
Okay. All right.
Thanks.
Number 3.
You didn't let any data calls through, did you? Because I was trying to call a BBS so I could perhaps set up my own, but you didn't support that yet, right?
That's correct. So we have attempted to. We have tried GPRS. I don't know if by data call you mean.
I mean pure GSM data calls.
Circuit switch data.
Like on a normal phone network.
Yes. So there is some code for that in OpenBSC. I'm not sure that it works with the NanoBTS. I'm not sure that the NanoBTS can do it at all. I don't think it can. So yeah, no, that was not possible to do here. Data you mentioned, so I'll also go on a tangent about GPRS. Previously, we've done some testing with GPRS, but we found out that actually the NanoBTS firmware is not so good at handling GPRS. So the NanoBTS tends to crash whenever we enable GPRS. It's fine if we don't load it very much, but so for testing in the lab, for example, it works. Or for making some proof of concept testing, that's fine. But for an actual test network with some hundreds of users, we brought 500 SIM cards. They were sold out in the first couple of days. I think just in the first 2 days. That kind of load, if putting all those SIM cards into smartphones, the smartphones will try to do lots of data traffic over GPRS, and the whole network would just stop working because the BTSs will be overloaded from the GPRS traffic. So we decided not to have that enabled.
Okay, thank you.
Yep.
Next question from microphone number 2.
Hello, I have 2 questions. One is, did you check the range that the network worked out? You said it worked on the train station, but did any other checks were made?
Outside the train station. The testing we did was inside the building, so we wanted to ensure that the indoor areas of the building were covered, and we noticed that from one corner to another of the building, so in the far ends of the building, on both sides, the signal was somehow spotty with the original plan of deployment or cell sites that we had in mind. So we modified slightly as time went on, and we made the last changes actually last night to move things around and to get even better coverage indoors. So as I mentioned, we have moderate to good coverage in all indoor areas, and the fact that it goes to Damtor is probably one of the base stations that happens to be near the window that actually also reaches out to.
And your answer brings me nicely to the second question I have. What was the procedure for initial testing for planning the placement of the base stations?
So we did that dry, actually. We looked at the drawings of the building, and based on experience from how the NanoBTS performed in the BCC in Berlin, we sort of estimated what kind of coverage we would get. As I mentioned, we were fairly worried about the walls, especially in this room, but it turned out to be not a problem at all. Not so scientific. There is some software for modeling GSM networks or radio propagation in general, which we didn't use. None of us have access to that, or none of the people who were preparing have access to that. And even so, it's not completely accurate. So it's a rather rough estimate, especially in an indoor environment. We opted for bringing extra equipment and being able to react to any problems that we found during setup. And yeah.
So just place the equipment and then run around with a phone seeing if it has range?
Pretty much, yes. It's not so scientific, but yes, it works. And of course, as we tried this in different locations, as I mentioned, the CCC camp was at the Finofort Luftfahrtmuseum, a little bit outside Berlin, an old airport, which is a museum now with bunkers for the airplanes. We got some experience with outdoor environment, and in the desert where I was helping out, I also got some experience with outdoor environment where there were a lot of caravans and mobile homes, which function similar to buildings in say, a street or an urban environment. They have metal walls, and those metal walls reflect the radio signal really well. So it was completely possible to have an excellent signal just standing in front of someone's trailer, and then you move 2 meters to the left, and suddenly you had no signal at all. That's kind of difficult. That's kind of difficult to deal with. You have to set up many more base stations, and then you need many more frequencies, and we are only so many people. That's also a limiting factor. The people who can come and help set this up in just a few days, especially around the holidays, can be tricky. So yeah, we did maybe a relatively small scale setup, but we of course try to improve every time, and every time we do it we learn even more about the things that we have to keep in mind and what doesn't work most of all. So I really encourage anyone who wants to try this out to look into getting the license and working together with some friends to get some hardware and set up a network nearby and play around.
Thank you.
Do we have a question from the blogosphere?
Yeah, one. Did anyone try to hack or exploit the network in any way while you were running it?
We're really disappointed to say no.
Oh.
Yeah. Or at least not that we know of. But yes, we were sort of hoping that someone would try to attack the network, but no attacks that we've seen.
Number one.
Hey, I have two questions. One is, what is the difference between a testnet license and a regular license?
Good question. I haven't gotten a regular license. So there are in the test license that we have, it's stated clearly that we are not allowed to connect to the public phone network, which we haven't done. That's I imagine the big difference. So for the test network, we run for a closed user group. We have only the people attending the Congress with the SIM cards. Whereas if you have a commercial network license, I imagine that you are allowed to sell services to the general public.
Well, the connections between the regular GSM network actually run quite fine, thanks to the POC guys.
Oh, so that has to be a misconfiguration then.
And the other question is about the base stations. I haven't had much experience with base stations, so what does it run your software? Do you have modified anything, and what protocol does it speak on the non-UM interface?
So the NanoBTS is not running our software. It is being controlled by our software, OpenBSC. The communication between our server running OpenBSC and the NanoBTS units that have been deployed is over TCP/IP. It's an OML. The protocol, communication protocol is OML, and the link is called ABIS.
Thanks.
We have time for the last three questions. One from number 4.
Yeah, I actually wanted to answer a previous question about DTMF. In their infinite wisdom, the IETF has defined multiple ways to transfer DTMF information over SIP and RTP. And they're also, in my experience with OpenBTS on Asterisk, FreeSwitch, and Yate, these are also supported inconsistently across different switching products. And what this means is that it's very easy to make configuration errors that cause very strange DTMF behavior. So if you saw multiple DTMF events, it probably meant that somebody had successfully enabled multiple DTMF modes simultaneously in the switch, and they were all working at the same time. So.
Thanks.
Nice. Number 3.
Yeah, regarding that shell via SMS, feel free to try it out. 9564. It's not running as root anymore. It's in a change root now and running at another user. It's a bit flaky, but feel free to try it out.
It's lots of fun. Thanks for setting that up.
And again, number 3.
Yeah, thanks. So I've seen multiple networks. One was 29C3 and the other one was Fairwaves. I guess the one was OpenBSC and the other was OpenBTS?
So the network where SIM cards could be used was always mobile country code 262, mobile network code 42. And that's also the number, the MCC and MNC on the SIM card. We, in the test license, and possibly, I don't know what it is like for the non-test license, but in the test license there is no statement about what MNC one is supposed to use for this radio system. We started using 262.42 some time ago, and we continue using that for the actual network that is that people can access. But we've also been doing some testing separately from that, using frequencies that weren't being used for the network running for the visitors, and probably those are the networks that you saw. In parallel. You might have been able to log on, you might not have been. They were used with separate SIM cards, I know, at times.
Okay, related question, is it possible to use existing SIM cards from commercial operators on these networks?
In theory, yes, if we would allow it, but then we are interfering with the services that the commercial networks provide, so we don't want to do that. Because if, as many of you may know, if the phone sees a very strong signal, it tends to go there. And if we would allow, well, actually, as long as it sees its home network, it won't go there. But say that you're walking around a corner and there's a slightly bad coverage of your normal SIM card, of your normal operator, then your phone will immediately jump over to the test network, and it won't necessarily go back because it's happy where it is in roaming, as the phone thinks that it is. So we don't want to interfere with the public networks, and thus we also don't accept anything but the SIM cards from here.
Okay, thanks.
Thank you very much, Peter, and the GSM group. Put your hands together, please.